In this video, we're going to talk about the unsigned char data type. So the big idea here is that if you're using C, you're probably writing your program in C because you care about performance. You need your program to be fast and you want it to use as little memory as possible. Maybe you even have a limited amount of memory. And so if you know what the size of, say, integers that you're going to be reading in are only going to be, in this case, 0 to 255. So in program 1, you are going to be reading in network addresses, and those are going to consist of 4 different 0 to 255 integers. If you used an integer data type, if you use an int, then you are reserving memory for a much larger integer than you need. I think ints in general are 4 bytes, and I think that allows you to go up to something like 21 million or 2 million or something like that. But you only need 0 to 255. And so by using the correct data type, you can save memory. So let me go over to an example program that I have just to go over these ideas. So first off, chars are actually an integer data type. And they're the smallest integer data type. They only use 1 byte, which is 8 bits. So if we think about 8 bits, we can score 2 to the 8th information. So that's 256. So if we can include 0, we can store 0 to 255. So if we want to use chars to actually store character data, then we should use the char data type. But since chars are ints, if we know that our integers will be small, we can use either signed chars or unsigned chars. So signed chars, pretty self-explanatory, but we can store whether they are negative or positive. So if we know that our ints were going to be between negative 128 and 127, we might use a signed char, or like in program 1, if we know we're just between 0 and 255, we can use an unsigned char. And so also, of course, ints are also integer data types. I guess really this would be ints, I'll say large-ish ints. So they can't be arbitrarily large, but they can be pretty large. So let's actually follow this link on the lecture page that gives us more information here. So if I click this link, I can scroll down to the integer types section, and I see a lot of information, and I can see, okay, an int, so we'll see that on our Linux server, ints are 4 bytes, so okay, it was 2 million, not 21 million. So they are going to go from negative 2 million to positive 2 million or so. Say we need an even bigger one, we would use something called a long. So this is here for you to explore, but the big takeaway is chars are integer types, and an unsigned char lets us store 0 to 255. And it only uses 1/4 the memory of an int. Let's get back to our program here. So the size of command can take in a variable and tell us how many bytes the expression in general uses. So here our expressions are just variables, but I could actually put something in there that would evaluate, and then the result of that would be what we would get back from size of. So when I go to compile this, I'm going to get a warning that size of actually gives me a long integer, I believe. But let's just ignore that. In your programs, you won't have any need to use size of, but we'll just ignore that warning because we'll still be able to print the size of. So the point here is we're going to be able to investigate how many bytes each of these takes up. So let's compile. And just like I said, we're getting these warnings. So I could just change this to LD, but because it's a long unsigned int is what size of is. But for our purposes, we're still going to get what we need. So we're fine. And let me just run this. So we can see that all of my char data types have size 1, so that they're 1 byte, which means 8 bits, but my int is 4. And then finally, when you're writing program 1, so you should store those parts of the network address as unsigned chars, and so you're going to need to read them in, and you're going to need to print them. And so for both printf and scanf, use the HHU placeholder for our unsigned chars. And so this is something that this is just an example. So var3, let's look where it is. var3 is an unsigned char, and here I'm printing it out, and I'm using that placeholder, and we can just, I guess we did make a change. So we can do that, and then let's run it. We can just confirm so the value of var3 is 12, so it printed, and we can even confirm that was indeed the value of var3. So that is how you use unsigned char data types and why you would use them to save space.